Let's add some movement to this scene. So to do that, as I said in the introduction, we need to define a model and view and projection matrices. So let's do that directly now in this vertex shader. I just noticed now that the vertex shader and fragment shader will get a little bit more complex. So maybe it's time to create new ones. So as you can see, I called the model view projection, and they are just copy paste from the previous fragment and vertex shader. So now let's go to the vertex shader and define 3 uniforms. Remember that uniform will be set once per draw command. So we define a matrix 4, that means a 4x4 matrix, which represent the model, and then one for the view and one for the projection. The position is simply the multiplication of these 3 matrices. We take the position vector, we change it with the model. So this is a simple vector matrix multiplication. Then the resulting vector will be changed with the view matrix. And again, we get a new vector, and that will be changed with the projection matrix. You can think of this multiplication as putting our position in the world coordinate, and by this one as putting our position in the camera coordinate, and then finally we are projecting into a plane, the camera plane. Let's go now to the Java code and define also these 3 matrices. As you can see, I defined 3 variables to hold each one of these matrices, and also 3 integers, which will hold the handle of these matrices in the shader program. I will also be defining 2 variables which will hold the width and height of our activity, and this will be important to set up the viewport for the OpenGL. Now let's go to the function on surface created and create these 3 matrices and then initialize them as identity matrix. That means we are not doing any transform. We also need to get the position of these 3 handles from the GL program. So let me change this name here, refactor it to GL program. And now, as you can see, we are getting a uniform location for the model and for the view and projection. So now we can use these 3 handles to set the value of these variables in the shader. We do that in the function on draw frame. So after we set the program, we can set these 3 matrices, and now we can rerun. As you can see, nothing has changed. That's because our matrices are identity. So first thing I want to change is on surface change. This function is called whenever our activity width or height has changed. So here we need to change the viewport. First, we save the value of the width and height to be used later. We set the GL viewport, as I said. So that's basically telling OpenGL the width and height of the surface which we are drawing on. Then we update the projection matrix using this OpenGL function called prespective. So we are putting our projection matrix to have an opening of 45 degrees, and we're telling the aspect ratio, and we are setting the near and far planes. So basically anything closer than 0.1 meter will not be drawn, and anything which is further than 100 meter will not be drawn. Now, if we rerun our program, not too much has happened because we are not changing our model matrix. Now, let's say we want to make this rectangle rotate around the y-axis. For that, we can, for example, in the onDrawFrame function, change this model matrix. For example, we rotate our matrix. So we have our model matrix, and we're rotating it like 3 degrees around the y-axis, as you can see here. Now we can rerun the program to see if the rectangles are rotating. As you can see, it's not happening. That means there is another bug. So let's run in the debug mode and see what's happening. You can see that our model is -1. That means it's not defined. So here we are not getting the correct location. Yeah, and that's because we did not use the correct program. So here we need to use our model view projection program. Let's rerun. And now we don't see anything, and that's because we are too close to the object. So I think we need to move our view matrix or our camera on the z-axis, a little bit on the z-axis. Let's do that. So I will do it once in the onSurface created and keep it fixed. So this matrix command is translating the view matrix with 0 on the x-axis and also 0 on the y-axis and -3. So basically we are moving the camera in front of the mobile. So now you can see we have two rectangles and they are rotating. Let's say we want now to rotate only the upper rectangle. For that, we need to change the model matrix before we draw the second one. Let's do that. So for that, let me define an identity matrix. And also here on the surface created, we initialize it with identity. Then, before we draw the second rectangle, we set the model matrix to the identity. So here we draw the first rectangle. Now we can change here the model matrix to identity. So now if we run the program, the first rectangle will be drawing while the second one is fixed. That's great. Now we have some motion in our scene. It looks now less boring, I would say. One last thing I wanted to do in this tutorial before we finish is to add the refresh rate. So how many frames we are drawing per second. And I want this to appear as a label here in the upper right corner of our activity. So to do that, first we go to the main activity here. This is the layout of our activity. So we can open it even in the designer mode. And I'm going to add a text view. And this text view, I will make it snap to the upper right corner. Let's see if we have done it correctly in the code. So as you can see here, we have the text view. Let me call it upper right text view. And as you can see here, it has a constraint and it's saying that the end of it is to the end of the parent and the top of it is the top of the parent. And that's actually what we want. The text, I will change it to frame per second, FPS. Now, if we run the application, we should see this label here. Yeah, it is here, but the font is very small, so we can increase it. So I put it to 20 SP. Now it should be a little bit larger. Maybe also let me change the color, the forecolor and background color so that we can see this number more clearly. So the text color would be now white, and let's put the background color to gray. We don't have a color gray. Let me define. So colors are usually defined in this resource file called colors.xml. It's here inside resources and values, then colors. So as you can see, we already have a white and black. So now we add another one called gray. And here we have the hexadecimal representing this color. So first we have the alpha component, then red, green, and the blue. So this will also be white. So let's make it gray by using 1F for the red, green, and blue components. Now if we rerun, as you can see, it's not more seen, yeah. And now you can see the new foreground and background color of this text. Let's go back to the Java and add the code to compute the FPS. So we will do that on draw frame. Basically, whenever we draw a frame, we want to count that up, and then we divide the number of frames which we drawn on the time we drawn these frames in, and that would be our refresh rate, or how many frames we drawn in the second. Let me define two variables here. So the first one will count the number of frames, and the second one will represent the time when we started counting the frames. I'll call it start time. I will initialize it from date.getTime. As you can see, this function getTime returns the number of milliseconds since this date. So this would be in milliseconds. Now, each time we draw a frame, we can increase the frame count, and we can compute now the current time and the number of seconds passed since last update. This would be the current time minus the start time and divided by 1000, since we're having milliseconds. What I will do, I will refresh this FPS every 1 second. So if more than 1 second has passed, I will update this number. So this will give us the new value of this number of frames per second. And we need to set the frame count back to 0. And we put the start time to be the current time. Now we need to set this label. Remember that we are using these bindings, as I said in the first video. Then we have that we named it upper right text view. Then we need set text, and we need to format this double value FPS. For that, I will use a decimal formatter, and I want to have all the complete numbers and 2 digits. That's it. Now we can put the value to be FPS plus the df.format. Let's now run the application. As you can see, the application starts and then crashes immediately after 1 second. And that's because whenever this function here is called, we are causing a problem since we are accessing this upper right text view from a different thread. So we're having one thread for the GUI where this text view is created, and here on draw frame runs on the OpenGL thread. What we need to do is to ask our activity to run on UI thread this simple code here. So use this function, run on UI thread, and it takes a runnable. And in this runnable, we only put this one command and we run. Now, as you can see, we get here the number of frames per second, and you can notice that it is updated almost every 1 second. Let me just clean this code here to put it in its own function. And I like to use lambda expressions here instead of having this runnable. So we can delete everything here, and we add this lambda. Now we can rerun, and still working. That's all for this tutorial. Thank you for watching, and see you in the next video. Bye.